Hi there, welcome. In this video, I want to talk about two different methods for graphing quadratic functions. First, the definition. A quadratic function has the general form of ax squared plus bx plus c, where a, b, and c are constants. The general shape is parabolic, either facing up or facing down, depending on whether a is positive for facing up or negative for facing down. The vertex can either be a maxima or a minima. If it's facing up, you can see the vertex would be a minima. If a is negative, the function will be facing down and the vertex becomes a maxima. In order for us to graph quadratic functions, we need to know a few key points. We have to know the vertex. It'll be useful to know the y-intercept and sometimes x-intercepts, and of course the axis of symmetry. The axis of symmetry is the line that divides the parabolic function into two halves. There is another method, which is graph transformation method. You can actually complete the square and turn the equation into a general form that looks like this, where f of x is equal to a constant times x minus h squared plus or minus k. And you can immediately get the vertex out. The vertex would be hk. And this gives you the transformation of the parent equation y equals x squared. And you should get the same answer using both methods. Let's go ahead and discuss this function here. F of x is equal to 2x squared plus 8x plus 5. In order to sketch this graph, we need to collect some information. First, I want to figure out what my axis of symmetry is. The axis of symmetry is given by the equation x is equal to negative b over 2a. b is 8, so it's negative 8 over 2 times the value a, which is 2. And we get negative 8 over 4, which is negative 2. So the equation for the axis of symmetry is x is equal to negative 2. And that's the dotted line here. Once we know the axis of symmetry, we actually know the value of the x for the vertex. So we can plug that x into the original equation and figure out y, and we have the vertex. Remember, the vertex is a point, xy. So vertex is negative 2, negative 3, negative 2, negative 3. So we have axis of symmetry, we have the vertex. We can also figure out the y-intercept, and y-intercept is when x is 0. So plugging in 0 in the original function gives you 5. So the y-intercept is 0, 5. Now for the x-intercept. The way we figure out the x-intercept is by setting the entire equation equal to 0. Because remember, at x-intercept, the y values are 0. Because the equation was given in ax squared plus bx plus c form, I had to do my discriminant first to see if I should even factor. And it turned out that my discriminant was not a perfect square, so I know not to try and factor this because I won't find one. If I'm really curious about where my x-intercept lies, I can quickly plug in to my quadratic equation and get a sense of where my x values will be. It turned out that they're both negative, so it helps me or guides me into how to sketch my graph. So this is my y-intercept. Here's my vertex. And a value is positive, so it's facing up. And using those points and knowing that my x-intercept will be negative for both of them, I'm able to sketch out my graph using those points as my guiding points. The second method is by graph transformation method, and this is where we get to complete the square. So using the same equation, you want to set that equal to 0, factor the number a out, and take the 5 over to the other side of the equal sign. Leave a good bit of space here because we will have to fill this in, and this is what you do. Take the middle term, divide by 2, and square it, which is 2 squared, 4. And that's what you put over here, and close the parentheses. Now, whatever you decide to put here, based on this little math here, you must multiply by what you factored out, which is 8, and that's the number you add on the other side. So what you now have is a perfect square trinomial, and factoring that out, you will get x plus 2 squared is equal to positive 3. Now bring the 3 back here on the left-hand side. You get x plus 2 squared minus 3 is equal to, and that's your function. And we can make a list of transformations. Here is shifted left, 2 units, shifted down, 3 units. So your parent equation is actually y is equal to x squared, and you already know that this is a parabola, but we have something else that we need to worry about, and that is the 2 here. This 2 means it's a vertical stretch. Okay, the best way to handle this would be to, first of all, you know this is your vertex here. Identify your vertex, which would be -2, -3, and you should already know that your axis of symmetry is right over here. Very quickly you can tell that the y-intercept is 0, 5, and to handle the vertical stretch, the best thing to do is to pick a number on either side of your axis of symmetry. Either side. So I want to pick a -3. So when I plug -3 in the original equation, -3 squared times 2 plus 8 times -3 plus 5, and that gives me -1. So I have one point is -3, -1. So -3, -1 might be here somewhere. Then I want to pick another point on the other side of my axis of symmetry. Let's say we pick -1, and -2 times -1 squared plus 8 times -1 plus 5 gives me 2 minus 8 plus 5. That gives me -6 plus 5, which is -1 again. So we can plot another point here, which is -1, -1. And now I have enough information to sketch the graph point. Now using this method, you can also get the x-intercept. And let's go ahead and see how. So 2x plus 2 squared minus 3. And to get the x-intercept, you need to make the y 0. And you can solve for x. 2x plus 2 squared is equal to 3. X plus 2 squared is equal to 3 over 2. X plus 2 is equal to plus or minus root 3 over 2. X is equal to plus or minus root 3 over 2 minus 2. And again, you don't get a nice integer that you can plot, but at least you can use this number and get a sense of where your x-intercept will be. All right, thank you very much for listening. I'll see you again. Goodbye.